Good evening, my name is Carlos Ortega. I'm a tutor for Data 8, and today we're going to be working on tables. To begin with, we're going to be working from problems from the summer midterm of 2017. Now, in this problem, to start off, we always want to find what information is given to us. So here we see that we're working with the NZ table. And it says it describes the immigration to New Zealand in the years 1979 to 2016. It includes the country they immigrated from, in what year, and the number of people that immigrated from that country in that year. So to start off in part one, it asks for the total number of people that migrated to New Zealand in 2000. So the first thing you always want to ask yourself is what table you're working with. In this case, we're only working with the NZ table, and that's already given, so it says nz.where. So since it says r equal to and it says where, we know we need to specify a value that's equal to and a column label right here. Since we're looking for the people that immigrated in 2000, that means we're going to work with year and r equal to 2000. This is going to make a table from NZ, but only with rows that have year equal to 2000. Now we're doing dot column, and since we want the total number of people that migrated in that year, we know we're working with values, since that's the number of people that migrated from specific countries in that certain year. So we do dot column value, and since we want the total, and this is currently just an array of people that migrated in 2000, we would do sum. And this would find the total number of people that migrated to New Zealand in 2000. Now, in part two, we want the largest value in the table. So it says the largest value, so we know we're working with the value column. And since we want the largest value, we know the first thing we're going to do is we need to sort it by value. And we know we need it from biggest to smallest because it pulls out dot item 0. So that means that whenever we pull out the first item, that has to be the biggest value. So the first thing we want to do is we do dot sort, and then we would do value, descending equals true. So this is going to sort it by value from largest to smallest. Now we want the largest value, and since we're doing dot item, that means we need to pull out a certain column as an array. And since we want the value, we're going to be working with the value column. So we dot column value. So that's it for part two. So part three of question one wants a total proportion of values that are equal to 0. Now, you might read it incorrectly and assume we want a proportion to the total, but in reality it says what we want is the amount of values that are equal to 0. So since it's nz and value, and we're looking for r equal to 0, we know we're using the where method. So we would do nz.where. We already know we're working with value. We want r equal to 0. So we would do r dot equal to 0. Now we want the total proportion of values that are equal to 0. And since what we've done in this line so far is that we called nz, but we only filtered through the rows that have value equal to 0, which means 0 people migrated from that country in that year. So we would do dot num rows, since each row specifies one country in that year that had 0 migrants. Now for part 4 of question 1, we want the average number of people that immigrated from Fiji each year. So since we know we want the average number of people, we already know we want to use the mean method from the NumPy package. So we would put np.mean. Now, we already know that we're trying to filter here because it says nz.where. And when we try to find out what to filter, we need to look back at the question. And it says the average number of people that migrated from Fiji. So we know that we need to only pull out the rows where country is equal to Fiji. To do that, we would do nz.where country dot r dot equal to Fiji. Now, We want the average number of people. So far, what we did, we filtered only the countries that have Fiji, and we're calling the average on all of this. But we need to find out how to find out, we need to pull out the total number of people. And it's the same way we did it up here. Now we need to call the column. We need to dot column to pull everything out as an array. We'll only write column since we already have the dot over here. We'll do column value. And this will pull out all the number of migrants for each year for Fiji. And at the end, it'll call them average on all of that. Now, for part 5 of this question, we're looking for an array of all countries with values over 10,000. Names can be repeated. So we know at the end of it, we want an array of the countries, of the country names. So that means the country column. And since we want it over 10,000, we know we want to filter. So we do nz dot where. We already were given value. So we do r dot above 10,000. And it's important to remember that r above is not inclusive. So 10,000 would not be included. Now, since we want an array of all the countries, that means that we want to pull it out all as an array. And to do that, we would use the column method. And since we want the country names, that means we're working with the country column. And that would be it for question 1. Now, for question 2, we once again want to check what we're working with. So here we're given 2 tables as the question describes. This one, the first one on top is happiness, on the bottom one is region. We see that regions has a country and it's given a region, while happiness has a country, its happiness rank as it's described in the question, its happiness score, and its rounded happiness score. Now, after you've digested all this information, now you know what information you're going to be working with. Now, in question 2, part 1, it asks for an array of the names of countries whose happiness score falls between 3 and 5. So it already gives us where, and as I said before, when you're working with a question, the first thing you want to find out is what table you're working with. Since we will know that we're working with happiness scores, and that's only the happiness table, we know that we're working with the happiness table. So we would do happiness dot where, and since we're working with happiness score between 3 and 5, we would do happiness score comma, and then we want between 3 and 5, so we would do r dot between 3 and 5. It's important to note that r between is left inclusive but right exclusive, so the 5 would not be included. But in this case, since it specifies between 3 and 5, we know that we're supposed to use the r between predicate. And since we want an array of the countries whose happiness, we want an array of the names of the countries, we know that we need to pull out the country column for that table that we filtered through. So when we do dot column, we do country. So as a run through of what's happening in this line, the first thing we do is we call happiness. And then we filtered using the where method through the happiness score, but only the ones that were between 3 and 5. And to finish it off, we're doing dot column country. And what this is going to do is going to pull out an array of the names of the country that have these filters. Now, for part 2 of this question, we're working with we want the name of the country with the lowest happiness score. And since we want the lowest happiness score, whenever you find out we want the lowest or the highest in a table, you know that you most likely need to sort. So, and since we were already given the happiness table, we would do happiness.sort. And since we're looking at the lowest happiness score, we would sort by happiness score. Since we didn't specify descending equals true, it's automatically going to sort this from smallest to largest, whereas descending equals true would be from largest to smallest. So then, now that we have it sorted by happiness score, and we want the name of the country with the lowest happiness score, we know we need to find that country. So what we do is the first thing we do is we want to pull it out as an array. So we do dot column country, and then since we want the first item of that array, since it pulls it out as an array, we would do dot item 0, and that would be the end of that part. Now in part 3 that's cut off, we want to find the number of countries on the list in the region with the most countries. So since this might be a little bit complicated at first read, we want to make sure we understand what we're looking for. So we want the number of countries. We know that we want the number of countries. And then we want the number of countries from on the list in the region with the most countries. So that means we need to find how many countries are in each region. Now, if you guys remember, in our regions table, we have 2 columns, country and region. And it's each country that we had in the happiness score. And each country is specified which region it is, but they're not grouped up. And since we now want to have the number of countries per region, we know that we need to combine all those. So first, we know we're working with the regions table, which is the first thing you always want to make sure. So it would be regions, dot, and since you want to group them up by region, you know that you're going to do dot group. So this is automatic. Since we did not specify a function, it's automatically going to use count. So that means since our other column is country, it's going to add a new column called country count. And it's going to be the number of countries per region. So since we have the setting equals true, that gives us a hint that we're supposed to use sort right here. And we want to find out what we're sorting with. But as I said, we want the number of countries in the region with the most countries. So we're going to sort by our new column, country count. And now we're going to do dot column, country count, or do dot item 0. So as a run through what's going on in this problem, first we call regions and we group it up by region. And since we did not specify a function, it's going to automatically just count how many of each value it has in common. So since our other one was country, it's going to find how many countries each have region, each have the same region in that row. And then we're going to sort by country count, descending equals true, which means it's going to be from largest to smallest. We're pulling out the array of country count, and we're doing dot item 0. Because we want, since now that we have the counts of the country per region, we want to pull out the number of countries in the region with the most countries. So now for part 4 of this question, we want the number of countries with a rounded happiness score of 6. So since we know that we're working with the rounded happiness score, that means we're working with the happiness table. And we already were given where. And we want to find where rounded happiness score is equal to 6. So we do dot where rounded happiness score, comma, and now we have a predicate. And right now, since we want to find the ones that are equal to 6, we do r dot equal to 6. And since now that we have this, we want to find a number of countries with that much. Since so far what this made is it's a table where rounded, with only the rows where rounded happiness score has a value of 6. And so since each row represents a country and want the number of countries with that score, we're going to do dot num underscore rows. So that's the end for part 4 of that question. Now for part 5, we see that there's going to be a lot of parts to it, so we want to make sure we take it step by step. So it says it wants a number of countries in Eastern Asia with a rounded happiness score of 4. So here we see it mentions Eastern Asia, which is a region, and a rounded happiness score of 4. So since that means we're working with the regions table and the happiness table. And since this variable right here is called with regions, we kind of get a hint that we're supposed to work with the we're supposed to somehow combine happiness and regions. And so we have blank dot blank comma blank, parentheses blank. So what we're going to do is since we're combining and we're looking at rounded happiness score, we're going to do happiness dot, and we want to group it. So we're going to group by country. And since we're grouping by country, then we're going to do regions. As you remember, regions is the other table we're working with. Since country is in both regions and happiness, it's automatically going to group them up by this column. It's automatically going to group them up by country. Now, counts equals with regions. So, we know that now we're working with this new table we just created. And so, we know that we want the counts of the number of countries in Eastern Asia with the rounded happiness score of 5. And so, we're going to use another method that's similar to group called the pivot. So, we're going to do with regions dot pivot, and now we need to give it 2 separate column labels. And since we want to find the combinations between regions and rounded happiness scores, we're going to do regions, comma, rounded happiness scores. So as you guys remember, when you call dot pivot on a table, you're going to give it 2 different column labels. The first one is going to be your new column, and the second one is going to be your rows. And it's going to try to do is going to find every single possible combination between these 2 columns. So now what we're going to use it for is at one point it's going to find a possible combination between Eastern Asia and all the rounded happiness scores. Now in the final part of this question, we're working with the one we just created. And it says counts dot, and it says r equal to. So we know that gives us a hint that we're working with the where method. So we're going to do dot counts dot where. And since we're trying to find something that's equal to 4, and we know we're trying to find where rounded happiness score is equal to 4, we're going to do where rounded happiness score. Now, what this is going to do is it's going to filter through all the rounded happiness scores, and it's only going to pull out the ones that are equal to 4. And so now we still need to find the number of countries in Eastern Asia with that score. So far, we've only filtered through all the countries with rounded happiness score. So now, since as you remember, I mentioned that since in pivot we mentioned regions as our first column label. Each region is now its own column. So at one point, Eastern Asia has its own column. So it's going to be Eastern Asia. While over here, it's all the happiness scores, rounded happiness scores. But we filtered through only the ones that are equal to 4. So now what we're going to do is we're going to call column Eastern Asia. And as you guys remember, since we called group at the very beginning, each input right here is going to be the number of countries. So each region has its own number of countries, but we also filtered where the rounded happiness score is equal to 4. So the last thing we're going to do is we're going to call dot item 0. So just as a quick recap in what we did in this last part, well, overall, first and with regions, we grouped up by country and regions. So this combined our happiness and our regions table by country. And then in counts, we used this table and we pivoted regions and rounded happiness score. So it was like this except they had all of this was rounded happiness scores, and all of these were all the regions. And so what Pivot did, it found all the possible combinations between regions and rounded happiness scores. Now in their last line right here, we called counts and we did dot where rounded happiness score are equal to 4, which is where this comes in. So it's going to be all these different regions, but only with the row rounded happiness score. But since we want the number of countries in Eastern Asia, and each region has its number of countries there that have rounded happiness score of 4, which it could be any number depending on, it's always going to be in the table. We want to pull out this specific column because we want to pull out this item right here. So we do dot column Eastern Asia and then dot item 0. And that's the end of this question.
Hey data haters, welcome back. This is I'm continuing Carlos's video on table methods, and I'm going to conclude it with an intro to conditionals like if, else if, and else, and for loops. So let's get started with number 3. The calories table has a list of food items from McDonald's, as well as its serving size in grams, calorie count, and calories from fat. And this other table categories has the food items and their categories. So the first question is, we want the total number of calories in every item on the McDonald's menu. So first, they give us this hint that we're using a calories table, so that's nice. And then what we're trying to do is get a total number. So when you see total number, try to think sum, or like you're adding everything together. So we're trying to sum something, right? So we're going to sum. What can we apply sum to? Well, sum works on arrays. And what's the classic example of arrays in data 8? Columns. So we're going to get the column that contains the values that we're trying to sum from the calories table. And the column we're trying to get is the calories column, because that's the one that contains the calorie values. So that's going to give us sum. That's going to give us the total number of calories in every item on the McDonald's menu. The next thing we want is the average serving size of all breakfast menu items. So the first thing we're going to notice is that our calories table doesn't have all the information we need. We also need this thing that tells us the category of the food item we're looking at. So we're going to get that from the categories table. And that's what they give us with this hint saying we need to create another table here. McDonald's equals this other table that's going to contain all of the information from the two tables. So when we're trying to merge two tables together, what we're trying to do is join them. Then that's the function we're going to use. We're going to join the two tables. So the way that syntax works is it's table dot join, then we give it the column in the original table, which is this one right here. So column 1 that we're trying to join, the name of the other table, and the name of the column in the other table that corresponds to column 1. So when we look at these two tables, calories and categories, we can see that there's the name of the food item is in both tables. So that's the column we're trying to join by. The column that has the values that are in both tables. So in this case, the first one that we're going to do, so we're going to do calories dot join, and we're going to try and put the item column, because that's the first column, that's the column in the categories table that has the values for the names. And then we're going to join it with the categories table. And we're going to join it with the food column of the categories table. So that's going to give us this table that looks just like calories, but in addition, it has a column called category with these values in it, and so on. So now we have this table called McDonald's with the values we want. So we're trying to get the average serving size of all breakfast items. So if we look at this like skeleton code, we can see an r dot equal to. And the function we normally use r dot equal to with is a where function. So we can go ahead and write that in, McDonald's dot where. So we're trying to narrow down the McDonald's table to only contain breakfast menu items, because that's what it wants the average serving size of. So we're going to do the category table, because that's the one that contains categories at breakfast. And we want them to be equal to breakfast. Next, we want to get the average. And np.mean only works on arrays. And if we can remember from the first question, the classic example of an array in data 8 is a column. So we're going to get the column that contains these serving sizes, and it's helpfully called serving size. Alright, so that's going to go through, join the tables together, narrow it down to where it's only breakfast items, grab the column serving size, and find the average for us. Now we can move on to the next question. Now we're trying to find the total variation distance between calories and calories from fat and all dessert items. So the first thing, it gives us like a helpful line, desserts equal. And just as a good testing strategy, use the names they give you. They're not trying to trick you with these. In 61A they might, but in this class they're trying to give you hints on how you should break down the code into different steps. So in this case, desserts equals, we're trying to get a table that only has desserts in it. So we're going to do McDonald's.where, and if you remember, the categories table had this column category that contained values like dessert, and McDonald's joined that with calories. So we're going to do McDonald's.where the category column r dot equal to, and we want the desserts, so we're going to do dessert. All right. The next thing, it gives us cals equals. So we're trying to get the calorie column, right? Because it's saying cals equals some column. So we're going to go to McDonald's, and we're going to grab the column calories. And then we're trying to get fat cals. So then we're going to go back to the McDonald's column, and McDonald's table, and we're going to grab the calories. I believe it's calories from fat. Let's go and check. Calories from fat. All right, and then you're gonna have like a nice little cheat sheet on the exam. So I'm also wrote myself a little cheat sheet because I kind of forget the total variation distance formula sometimes as well. So here's the total variation distance formula. It's 1/2 times the sum of the absolute value of column 1 divided by the sum of column 1 minus column 2 divided by the sum of column 2. So let's just fill that in. We already have our two columns that we're trying to do, the cals and fat cals. So we're going to do 1/2 times the sum of the absolute value of column 1, which is cals, divided by the sum of cals. And then we're going to subtract that from column 2, which is fat cals, divided by the sum of fat cals. And that's the total variation distance. So now let's go to the last part of question 3, which is making a calories table with an extra column called fat proportion, describing the proportion of calories that are from fat for each food item. So when we see that we want to add a column to a table, there's one function that comes to mind, which is with column. So we're trying to add it to the calories table. So we're going to do calories dot with column. Don't forget the underscore. With column, and the worksheet seems to have left out a line. So let me fix that line. Can't So now we have calories out with column, fat proportion, and we got to give the column, the array that contains these values, the fat proportions. So the fat proportion is going to be equal to the calories from fat divided by total calories. And we already have two columns that describe this top and bottom, so all we got to do is divide them. So we're going to go to calories. We're going to grab the column. Oh man, writing too fast. We're going to grab the column that has the fat calories, which is called calories from fat. And we're going to divide it by calories dot column, and we want to get the calories and that's our fat proportion. So now we're going to move on to some conditionals, and oh man, I'm in the wrong one. Now we're going to move on to conditionals and for loops. So conditionals are statements like if and elif and else. And what they do is they let us control what the program is going to do based on different inputs. So let's do a really simple example just to get our feet wet with these if-else statements. So let's say we wanted to make a function that takes in a price for tuition. And if the tuition is above 40,000, we want to print that price is way too high. So we're going to print that price is way too high. Then if the price is above zero but below 40,000, we're going to print, all right, we're all right, we're chilling. And then if it's zero, then we print, yay for scholarships. Alright, so how do we write this function? So the first thing is we do the def, that's the keyword for creating a function. Then we give it the name of our function, which we're going to creatively call tuition. And then we're going to give it the operand, which is price. Don't forget the colon because Python syntax. And then we're going to check for these values. The first thing we want to do is check if price is above 40,000. Sorry, I just stated your price is way too high. So we're going to print that price is way too high. You need to cut it. And then the next thing we want to do is check if it's above zero. And what we already know is that anything that's above 40,000 is going to go through this line. So if we do an else if, we just have to check if price is greater than zero. So we already know that it's less than 40,000 if it's getting to this line. So if price is greater than zero, we want to print we're chilling. Then finally, if it's none of those things, we want to print yay for scholarships. So if we were to pass in values to this tuition function, tuition of 89,000 would print that price is way too high. Tuition of $64 would print we're chilling. And then tuition of 0 would print, of course, yay for scholarships. So that's kind of how we can use conditionals. That's like a really easy example of how they work. A lot of times we'll be checking if something's greater than something else, or we'll check if a column has greater averages than another column or something like that. But this is just supposed to be a basic intro, and we'll learn how to use it more for Data 8 as we move on with the course. So now let's get into for loops. All right, for loops. So what we use for loops for is iterating through stuff. So if we have, it's typically iterating through some sort of array. So like a really basic for loop would say for I in np.arange 0, 5, and we're going to print I De Niro. Oh shoot, let's capitalize his name. I De Niro. Then we're going to print I Wagner. So what does this do? So let's start. First we have the keyword, which is 4. Then we have this I. What does I do? So I is the name of a temporary variable that's only used while the function is looping through this loop. And what it does is it'll go through this array. So np.arange is actually an array, right? With like 0 through 4. And the first time it goes through the loop, it'll say set I equal to 0. Then it'll say, the second time you go through, it'll say set I to 1. Then it'll say set I to 2, set I to 3, set I to 4. So in this case, we're not really doing anything with I, so it doesn't really matter too much for this for loop. But there definitely is times when you use the variable that you're defining within the function. And I is just the classic name for the variable that you're using as your iterator. And yeah, so then we have in, which is saying, then we have in np.arange. So we're saying for each value in np.arange, do this function body, which is right here. And we're going to print hi De Niro and hi Wagner. So that's just going to print hi De Niro, hi Wagner, hi De Niro, hi Wagner, like 5 times. And then it'll all just close. So that's really basic for loop. What we'll use for loops for in this class is primarily for like looping through. Like one big use is when we're doing sampling, when you have to do it like 5,000 times. So you give it your function body and you say to do this thing 5,000 times. Or like another cool example I could come up with is, let's say we have like the NBA table that we use all the time in this class. And we have the name of the player, and we have the position, the age, and yeah, so this table would be like LeBron James, power forward, and 32. Oh, and height. And he's 6'8". So that would be, and then you have all the other players. So let's say we wanted to go through this table, and for each player, we want to print out this string that says, like for example, for LeBron James, it'd say LeBron James is a power forward. He is 32 years old. And 6'8". So what we could do is make a for loop that goes through every row in the table. So we're going to say for I in NBA dot column name. So now we're looping through every name in the column, in the table. And what we want to do is print this string that has those 3 aspects in it. So the first thing we know is that I is equal to the name, because that's like the temporary variable that is assigned to each value in the NBA.column name. The next thing we need is the position. So we're going to say POS equals NBA dot. So what we're going to do, the strategy is to go through the table, get the row where this player exists, then grab the position out of it. Then get the row where this player exists and grab the age out of it. Do the same thing for the height. So we're going to do NBA.where. So since you never want to repeat code. So what we're going to do is instead of assigning this to position, we're going to go ahead and create this table and we'll just call it character row. I mean, not character row, sorry, player row. And player row is going to be equal to NBA.where the name is equal to our name. In this case, that's just I. Then we want to assign position to be player row dot column position dot item 0. Then we're going to assign age to be player row dot column age dot item 0. Then we're going to assign the height to be equal to player row dot column height dot item 0. So now we want to print that string for each of them. So we're going to have this big print statement that says print I, which is the player's name. Then we're going to add a string that says, so we're going to have a space because we don't want it to say LeBron James is. We want to say LeBron James is a. So we're going to have a little space here and say is, then a, then another space after it. Then we're going to add the position. Then we're going to add a comma, space, he is. And the reason we can use he is because NBA is all for guys, and so we don't need to worry too much about pronouns in this case. So he is, then we're going to add age, so he is, and then age was lowercase, and we defined it. So we want to make sure it's lowercase. And then we're going to add the string saying years old, and he is, and his height. Alright, so if we were to run this with the actual NBA column, it would go through all the positions, all the players, and print this string for them. And that's a pretty basic intro to for loops, and I hope this helped. Feel free to reach out to us in office hours or anything else as you're preparing for this midterm. And good luck!